Section 2, we're going to talk about perpendicular and angle bisectors. So here you have some information about perpendicular bisectors. There are two useful theorems to remember about perpendicular bisectors. So the perpendicular bisector theorem, if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So what that means is, notice here, this is a perpendicular bisector. Notice that it takes my line segment AB and it splits it into two equal pieces and it forms a right angle. When I have that, any point from X to this line segment is going to be congruent. So notice here they labeled 3 and 3 to show that from X to A and X to B have the same measurement. Now the converse of that theorem just says if I'm given different information, I can still conclude the same thing. So notice that in this picture they labeled 3 and 3. And I have my pieces here to show that C and D has been separated into two equal segments. So therefore I can conclude that this line segment here is a perpendicular bisector. So for our practice problems. So for your example that's given here, what is the value of X? Notice that these two pieces are the same. So therefore I can conclude that this is a perpendicular bisector, so these two segments should also be the same. So notice X is equal to 4. So in problem number 1, I have my two markings indicating here that this segment and this segment are congruent. I have my right angle. So therefore I can conclude that these two pieces here are also congruent. So X is equal to 8. Number 2 is the same type problem. These two are congruent, so therefore I can conclude that these two pieces should also be congruent. So 2x equals to 4, so x is equal to 2. So 2 times 2 gives me 4, which is what I needed. Problem number 3 is very similar, but your triangle is flipped upside down. Don't let that discourage you. These two pieces are congruent, so therefore I can say that these two pieces are also congruent. So 2x minus 3 is equal to x plus 2. I'm setting them equal and I'm solving for x. So I'm going to add 3 to both sides. 2x is equal to x plus 5. Subtract x. X is equal to 5. Now notice in these problems it asks me to solve for x, so I'm not plugging anything back in. I'm just finding the value of x. Now on the back side, we're going to talk about angle bisectors. So my angle bisector theorem, if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So your picture here is showing you that you have a 4 here and a 4 here. I have two right angles, and my angles are congruent. So this piece here is my angle bisector. Bisector means to cut in half into equal pieces. So these two angles here are congruent, so I can say that my two pieces here touching the angle bisector have congruent measure also. So for our practice problems, here I have an angle bisector. I know that because these two pieces here have the same tick marks to indicate that they are congruent. So therefore my angles are going to be congruent. So if this angle here is 70, this angle here is also going to be 70. Problem number 8, similar picture, I'm just looking for something different. So my two angles are congruent. I have my two right angles here, so I know that this is my angle bisector. So I can set these two pieces equal to solve. So I'm going to divide by 3. So x is equal to 4. Problem number 9, similar type problem. I know that these two pieces here are congruent, so therefore my angles are also congruent. So 4x is equal to 2x plus 20. I'm going to subtract 2x from both sides. 2x is equal to 20. Divide both sides by 2. X is equal to 10.